Hi, in this video, I'm going to discuss computing slope and aspect in QGIS and show you how to do this. So this is done using the Raster Terrain Analysis toolset in the QGIS processing toolbox. We're going to be running the slope tool, which produces a raster where every pixel represents the slope angle in degrees. And I should mention that sometimes you have to produce slope in percent. So there is a slope tool in the Google toolbox in the processing tools in QGIS that will allow you to produce slope in either degrees or percent. But we'll just be using the native QGIS tool, and then we'll run the aspect tool, which will produce a raster where every pixel has a numeric value indicating the slope direction. And there are other tools in this toolbox which can be very useful for some analyses. Terrain ruggedness index, which is a measurement of the terrain heterogeneity, or in other words, what parts of the terrain have more complex landforms and which are flatter. And then there's also one for generating hillshade. So we've just used the hillshade renderer here, but there's also a hillshade algorithm that would allow you to output a raster for that. So this is what aspect will look like when styled using a circular color ramp. So a circular color ramp is one where we have the beginning and ending color of the color ramp being the same. So north is represented by cool blue colors, south by warmer yellows and oranges, and the east and west intermediate colors. And so it gives a more intuitive view of the data. So with the aspect tool in QGIS, north will be represented by values between 0 and 360, south 180, west 270, and east 90. Some GIS tools will produce different values for aspect, so it's always important to know what the values represent based on the tool that you've used. So calculation of slope is basically determined as this formula, the arctangent of delta z over delta x for degrees. So slope is calculated as what's called a focal operation or a moving window operation. And so we can see in this raster on the right, if we're talking about this one pixel here and we're going to compute slope for that one pixel, the software will look at the window of the 8 surrounding pixels and it'll use the steepest slope in the window and assign that as the slope for this pixel, and it will then move on to the next pixel. And it moves through the entire raster in this fashion. One important thing to mention about this is it can lead to edge effects. You can imagine if you're calculating the slope for an edge pixel, you do not have the 8 surrounding pixels in that case. So you can end up with odd results for the pixels around the edge. Sometimes people will export a raster, kind of buffer their study area, in other words, to account for this issue, this edge effect. And this is what slope can look like, where we've styled this where the steepest slopes have red colors and the flatter areas dark green. So let me get out of this PowerPoint presentation and into QGIS. So here I am, and I have kind of finished with day one where I've have my land cover aligned and my terrain aligned. And we're going to be focused on the terrain data set here, and we're going to make sure we use terrain aligned when we run these tools. So the first one we'll run is slope. So I'll open up the processing toolbox and find the Raster Terrain Analysis toolset and double click on slope to open up the tool. These are fairly simple tools to run. The input is just the elevation layer, and we want to again make sure that we're using the aligned terrain so that the slope will be aligned by default. The Z factor isn't something you have to concern yourself with here because our X, Y, and Z coordinates are all in the same units, meters. In some imperial unit situations where you may have X and Y in meters and Z in feet, you may need to adjust the Z factor to convert between feet and meters. But here we don't need to worry about that. We can just simply use the default of 1. And I'm going to save this out as a geotiff. And I'll call the output slope. Click Save, and then run the operation. Click Close when it's done, and here I have my rendering of slope. And QGIS will always use the single band gray renderer by default for a new raster. So we're going to switch this to a single band pseudo color, and we're going to change the color ramp out. We'll use red, yellow, green. And we want to invert this so the steepest areas are red. So now if we zoom in to this area up here, we can see that some of these steeper slopes are red and the flatter areas are green. And it's always good to spend a little bit of time styling your outputs just so that you can make sure that the data looks correct and the operation went according to plan. Next, we'll generate aspect. And again, we want to make sure that terrain aligned is used. It will usually pick the last raster you've interacted with. So slope may be selected here, and if you try to generate aspect against a slope layer, you'll get a very strange result. So make sure terrain aligned is selected, and we'll save this out as aspect. And again, I'll click run. We don't have to worry about the Z factor. And we have the aspect generated here. So with aspect, we can implement a circular color ramp. And I have saved one in the course material. So I'm going to open up layer properties, and from the symbology tab, go down to this style section and choose load style. And if I go into the course data, you'll see an aspect circular color ramp QML file, which is a QGIS style file. And I'm going to click open and OK to apply this to my data. And now I can see that the colors to the north, the 0 and 360 values, have a cool blue color, and the south-facing slopes are more yellow. In the next video, we'll look at reclassifying rasters.